Welcome. In this lecture, we have to solve the examples solvable for x and solvable for y by using those methods here. In the last lecture, we solved the first order and higher degree differential equation by using the method solvable for p. So now we have to study here what is the method solvable for x. Okay, equation solvable for x. Equation solvable for x. Okay, so what is the method solvable for x? So we know the differential equation, so that is a first order and not a first degree differential equation. So to solve the equation, f of x, y, p is equal to 0. X, y, p is equal to 0. So this is equation number 1. Okay. So solve this equation. To solve the equation here, f of x, y, p is equal to 0. So solve for x. We can express x explicitly in terms of y and p. Okay, so we write this equation in the form here. So this is x is equal to something f of yp. So write the equation, write the variable x in terms of y and p explicitly. Okay, so this is equation number 2 here. Okay, 2. So differentiating this equation, equation 2 with respect to y, we get. So what is the derivative of this with respect to y? So derivative of this is dx by dy is equal to f of y, p, and the derivative of p with respect to y. So this is a dp by dy. Okay. So after differentiation, so this become this. So this is a dx by dy, and derivative of this f of yp. So this is a function. So derivative of this is the function of f y, p, and dp by dy. So what is the dp by dy? Derivative of p with respect to y. So after differentiating this, we get this. Okay. So we know that. So what is dy by dx? Dy by dx is p. So dy by dx is p. So what is the dx by dp? So dx by dp is equal to 1 upon p. So dx by dp is equal to 1 upon p here. So this involving only two variables, y and p. Okay. After solving we get. So solve this equation. So 1 upon p is equal to this. We get the solution here. We get phi of something y p and integrating constant c is equal to 0. So this is equation number 3. After solving this, we get the solution, that is the phi of y p c is equal to 0. So in this solution also we get p is a dy by dx. So what is the solution? If we remove derivative, if we remove dy by dx, if we remove p, then we get solution. So what is the required solution here? So this is equation number 2 and this is equation number 3. Then eliminating p from equation 2 and 3. Eliminating p from equation 2 and 3, we get the required solution. Eliminating p from 2 and 3, we get required solution. We get required solution. Okay. If p is not eliminated from this and this, then what is the solution? If p is not eliminated, then what is the solution? If p is not eliminated, from 2 and 3, if p is not eliminated from 2 and 3, then solving equation 2 and 3 separately, 2 and 3 separately, we get, so that is x is equal to, so we solve this, we get this phi 1 pc. So c is an integrating constant, solution of this is this, and solution of this is something x is equal to phi 2 pc. So p is also there. So first we eliminate p from this and this, we get required solution. If p is not eliminated, then we obtain this solution separately here. Okay. Then what is the next step here? So these two equations together we get the required solution. So write these two equations together form the general solution of the given equation. So okay, so we take one example of such type. So solve the example here and how to write the given equation in a solver for x type and how to solve that equation here. So very simple method is there. Okay, so we take a simple example. Solve y is equal to x plus p square. Y is equal to, so just sorry, x is equal to y plus p square. Solve this differential equation. So this is a first order, p is a dy by dx, first order but second degree equation here. The solution. So this equation is of the type, so x is equal to, so this is solvable for x is equal to f of yp. So here already yp explicitly occurs here. So this is x is equal to f of yp. So this is a function of y and p here. Okay. So by using method differentiating it with respect to y, we get just we follow the earlier method. Yeah. So what is the derivative of this? This is a dx by dy. So this equation here, this is equation number 1. So dx by dy, differentiate this with respect to y. So what is the derivative of this? Y, derivative of y with respect to y is 1 plus derivative of p square is 2p into derivative of p with respect to y. So that is the dp by dy. So this is the derivative here. Okay. So put dy by dx is equal to p here again. So what is the dx by dy? So this is 1 upon p. It's so very simple here. Okay. So that is 1 upon p is equal to 1 plus 2p dp by dy. dp by dy. Okay. It's so very simple. So then what happened here? So this is 2p dp by dy. We solve this equation. 2p dp by dy is equal to 1 upon p minus 1. So this is what? 1 minus p divided by p. Okay. So this is 2p dp by dy is equal to dp by dy. So now we separate the variables. So coefficient of dp is the function of p only, and coefficient of dy is the function of y only here. So this equation can be written as, just we write this as dp by dy is equal to 1 minus p divided by 2p square. So by variable separable type, so what happened here? So this can be written as 2p square divided by 1 minus p dp is equal to dy. Okay. So this is a variable separable type. So function of dp is the p only, and function of dy is the constant here. So on integration, this can be okay. Before that, so this can be write it in the form here. So this is by partial fraction. So this is equal to 2 into bracket p plus 1 plus 1 upon p minus 1 by using partial fractions. So what happened here? P plus 1 into p minus 1. P plus 1 into p minus 1. So that is a p square minus 1 and plus 1. So minus 1 plus 1 get cancelled. Only remaining here p square. 2 is here and p minus 1. So that is 1 minus p is here. I think p minus 1 here. Just p minus 1. Just what happened here? Minus 2 is there. So okay. P minus 1 is here. Okay. Then, so what is the integration of this? So on integration, one minus p divided by 2p square. So 2p square divided by 1 minus p is equal to dy. So just okay, this is correct here, I think. Okay, this is correct. On integration, so what is the integration of y? So this dy is equal to y. So minus 2, okay, dp here, minus 2. What is the integration of p? So that is p square by 2. So this is what is the integration of dp? So p plus log of p minus 1. Okay, p minus 1 plus integrating constant c here. So this is equation number 2 here. This is equation number 2. So what is the next step here? So using this equation, so x is equal to y plus p square. You can find, eliminate p from 1 and 2. Eliminate p from 1 and 2. We get a required solution. Or simply, what is the p here? So this is x is equal to y plus p square. So what is p? So this is p square is x minus y. Then what is p? P is what here? Square root of p is equal to square root of x minus y. So put this value of p in this equation, we get required solution where p is eliminated. This is very simple. Okay. So this is the solution of this differential equations. Okay. So now we take the another form to solve that equation. So this is a solvable for y. So equation solvable for y. Equation solvable for y. Equation solvable for y. Same method here. So all do we study what is the method that is the equation solvable for y, x. So now we study here the equation solvable for y. Okay. To solve the equation f of x, y, p is equal to 0. F of x, y, p is equal to 0. So that is equation number 1. So solve for y. Solve for y. We can express y in terms of x and p. We get okay. So this equation can be written in the form, so that is y is equal to something f of xp. So this is equation number 2. Y is equal to xp. In the last method, we write x is equal to function of yp. Means here y occurs in terms of x and p explicitly. So we separate x and p from y. And we write this equation. So differentiating it with respect to x, we get. So what is the derivative of this? So this is the dy by dx is equal to something f of x, p and dp by dy. Okay. After differentiation, we get there what type of terms there after differentiation? X is there, p is there, also dp by dy is there. Okay. dp by dx is there. dp by dx. Okay. So on integration, after solving this, so this is p here. Put dy by dx is equal to p, and taking integration, we get, taking integration of this, we get the solution such that x is there, p is also there. So EC is an inconstant is equal to 0. So this is equation number 3. Okay. So P is also here, P is there. After solving this, we get this solution here, but P is there. We remove P because P is dy by dx. So what is the solution? To obtain solution, we remove P. So how we can remove P? So that is eliminated P from equation 2 and 3, we get required solution. By eliminating P from equations 2 and 3, we get a required solution. So similarly, if P is not eliminated from those equations, if P is not eliminated, if eliminated, then okay. If P is not eliminated from those equations, then we obtain the separate solution, and then these two solutions taken together is the complete solution. So this is the solution of this is a method to solvable for y here. Okay. So now we take an example of such type. So very simple example. Take an example. Solve p cube plus p is equal to e raised to y. Solve. So p cube plus p is equal to e raised to y. So write this equation in the form like that, solve for y. So how to write this equation? So solution. The given equation can be written as can be written as so taking logarithm of both sides. So what happened here? So that is log y. Log of e raised to y is equal to log of p into bracket p square plus 1. So we take common here p from this term. So p into bracket p square plus 1. Okay. So what happened here? So y is equal to y into log e. So this is log of p square plus 1. Okay. So what is log e? So log e is 1 here. Okay. Log e is 1. So therefore y. So log of ab is equal to log a plus log b. So this can be written as log p plus log of p square plus 1. So we say that. So here we say that. So y occurs here explicitly. So just we write here. So what is the solver for y? So y is equal to function of xp. So we get this equation in this form here. X is not there explicitly, doesn't matter. So we get this equation in this form. Y is equal to xp. P is there. So y is occurs separately. Y is equal to something. X is not occur explicitly, doesn't matter. So differentiating it with respect to x, we get. So what is the derivative of this with respect to x? So this is dy by dx. Okay, dy by dx. Okay. So what is the derivative of this? So what is the derivative of log p? What is the derivative of log p? So 1 upon p plus, what is the derivative of this? 1 upon p square plus 1 p square plus 1 into derivative of p square plus 1 is 2p into dp by dx into dp by dx. So what is the dy by dx? So this is p here. So this is p here. Okay, this is p. Then this equation can be written as, so dividing p throughout. So dividing p throughout. So this is 1 is equal to 1 upon p square plus 2 upon p square plus 1 dp by dx. Okay, dp by dx. So just so bracket is there. Okay, because what is the derivative of log p? So that is 1 upon p into derivative of p is a dp by dx. What is the derivative of this? So 1 upon p square plus 1 into the derivative of p square plus 1 is a 2p into dp by dx. Okay. So p is cancelled here. So we get this. P is cancelled. I think this is a p square here. Okay, p square. So by variable separable type, what happened here? So by variable separable types. So what happened here? So this is a dx is equal to 1 upon p square plus 2 upon p square plus 1 dp. Okay. So what is the variable separable type? So coefficient of dp is the function p only and dx is the function of x only, or constant here. So on integration. On integration. So on integration we get. So what is the integration of this? This is x is equal to. So this is 1 upon p square. Okay, p square. So what is the integration of 1 upon p square? Is minus 1 upon p, because derivative of minus 1 upon p is 1 upon p square. So integration is this. So plus. What is the integration of this? This is 2 tan inverse p. 2 tan inverse p here. Because it's a derivative. What is the derivative of tan inverse x? 1 upon 1 plus x square. So the integration of this is 2 as it is tan inverse p. Okay. Plus integrating constants. So this is equation number. So this is equation number 1. And this is equation number 2. Okay. So what is the solution of this equation? So we eliminate p. We eliminate p from equations 1 and 2. We eliminate p from equation 1 and 2. We get the required solution. Okay, we get the required solution. So this equations is the solvable for y. In first we study the equation solvable for y. Before that, the differential equation can be factorized, and then we solve. So that is the solvable for p. Then we study here the equation solvable for x, and this method is equation solvable for y. Okay. So tomorrow lecture we have to study another method. So that is a Clairaut's method. Okay, to solving the first order but not a first degree differential equations. So we stop here. Before that, I request you to like and subscribe the video here, so you get so many lectures of this series. Thanking you.